Welcome back, y'all. I'm here ready to install my receptacle and my breaker to finally have this circuit hot and ready to use for power. So in the last video I installed the receptacle box here, and I ran this home run wire which goes to the cell panel here. So now I'm going to finish off by installing the receptacle. And before I do that, let me just look this over. I'm going to be installing a GFCI receptacle, or a GFI receptacle, a ground fault circuit interrupter. The reason why I'm going to be doing this is because this part of the house that I'm working on is the garage, and the NAC, the National Electrical Code, states that there's several parts in the garage, and not in the garage but in the house, that can have ground fault circuit protection only, and you're not required to have arc fault. And that one of the sections of the house is your garage or your bathroom or your kitchen and so forth. And I can leave that that section of the code on the description. That way you guys can also look at that and use it as a reference when wiring a house. All right, well, with that, I will be installing just this GFI receptacle and not a GFI breaker. And that's because GFI breakers are a lot more expensive, and this would comply with ground faulting the circuit. And yeah, that was a big price difference. So for now, we'll just stick with this. And also because it's only for one receptacle outlet here, which I'm okay with. All right, so first off, what you want to do is you want to get your cable ready here. And by ready, I mean you got to get these wires ready to land on your receptacle. To do that, I like to have a nice sharp blade. Always have a sharp blade. Never have a dull blade, because then you can injure yourself. All you got to do is remember to leave 1/4 of an inch sheathing inside the box of this cable, and then the rest you can take off. So I like to just score it lightly. You don't have to go in deep, because then you can damage the insulation on the wires. Score it, and towards the end you can dig down and cut it loose. And all you can do is pull it back now, nice and easy. And now you can cut your excess sheathing here, like so. Always remembering not to damage your wire insulation. And now you can take off this paper. Now that you have your wires, what I like to do is I like to put my ground to my left, my black wire to the right, and the white in the center. And I'll show you why in a minute. But I like to start folding my wires like so, all the way back, straight back. And then you can go ahead and give them their shape, their form. And there you have your wires basically ready to go here. And what I like to do too is, at this point, I can cut them a little bit shorter, because initially I did leave this wires longer, but I'm going to cut them shorter so I can be ready to install them on the receptacle. But before I do that, always keep safety first. So I like to always start at this part of the box, because I know that there's no power. And if I start on the receptacle side, I can turn on the power by accident and have current flow down the stream. But always double make sure that your circuit that you're working on is dead. So one way I like to do is first test something that's hot, and I know this sub panel is hot. And then from there, test your wire. Obviously this wire is now landed, so it's not going to be hot. But let's say that I'm working far away from the panel, and I'm, let's say, in the crawl space, and then I'm going to test for if it's hot or not. And obviously it's not hot because it's not landed. But now we know that for a fact. Now I can go ahead and cut my wires, so I can be confident that I'm not going to get shocked, or I'm not going to short it and damage my tools and hurt myself. All right, so this is 12 gauge wire. So all you do now is you grab your wire strippers, and you go to your 12 gauge stripping hole, which is second to end on my strippers, and then all you do is strip it. So just as a quick review, the GFI, you can loop around the screw, or you can side feed it right here on this receptacle. I like to always loop them, so I'm going to go ahead and loop them. The manufacturer specifies that if you're going to loop it, you got to strip your insulation on this wire at least 3/4 of an inch if you're going to loop around the screw. If you're going to stab it on the side, then it recommends to strip only 5/8 of an inch, a little bit shorter, because you don't want the insulation bare wire to be sticking out as well. So I'll go ahead and do that now. I'm going to loop it around, so I'm going to go 3/4 of an inch. You don't have to measure it, but maybe you have to at the beginning just to get practice. But once you have the practice, you could just, once you have the practice and idea, you can just do it without even measuring it. So I'll go ahead and just strip it like so, and strip it like so. Just keep them nice and straight, and then back off a little bit after you come down on it and pull out, and the wire comes out relatively easy. So as I mentioned, I'm going to loop them around the wire. I like to use needle nose pliers, and always wrap these on the screw on the same direction that it tightens down. So I know that these screws tighten down clockwise, right? So my neutral goes on my left hand side, which is my neutral part of the outlet, and my black or hot wire goes on the right side, which is the obviously the hot part of the outlet. Small slot is hot. That's one signifier, or one way to know. The other way to know is that your screw is a brass screw or golden screw, as opposed to your neutral, which is a silver screw. All right, so I know I'm going to be going clockwise, so this wire I'm going to turn it this way, clockwise direction, and then black I'm going to go clockwise on the other side, so I'm going to go fold it this other direction like so. And then there's my ground. Okay, so the ground, I'm going to just stab it in straight, so that way you can also see how that's done. So all right, so now that I have my wires basically ready to go, folded the way I want them, and folded where they're going to land on the screws of this receptacle, now I usually take my receptacle and undo my screws like so. I like to back them off all the way out. Okay, this is the wrong one. This is a size 2. Let me get the correct. Oh, that's not the wrong one as well. Sorry about that. Let me see. All right, so now I'm gonna just back these up. Back these up as further out. That's gonna make it easier for me to loop my wires. So now I'm gonna go ahead and land my. First, I like landing my ground like so. Put it in, tighten down, and then I also like to give it one more nice tighten with my hand. Get some good torque in there. Tighten that down, and then I like to land my neutral. Like I said, it's going to be on the silver screw, which is the left side of the receptacle, looking at it straight ahead. Tighten it down with my screw, and then tighten it down with the screwdriver. Make sure I get enough torque in there, nice and good. Same with this black screw. You can also loop it around better. You can grab the, hopefully you can see that. Just grab the wire with the needle nose pliers and try to loop it around the screw, and then tighten down your screw. Tighten down your screw even more. Then you have your receptacle ready to go. What I like to do also is tape my receptacle. The reason why I like to tape it is because it just offers more protection to the person that's going to be using it in case, or working on it, in case they need to pull the receptacle out. At least the tape is there to prevent maybe potential shock. The good thing about GFCIs is it's meant to protect personnel, so people. It's meant to protect you from a shock. GFIs are rated to trip or turn off when there's an imbalance of current that is 5 millimeters. Oh, I'm sorry, millimeters. That's the measurement. 5 milliamps of current. So when you have 5 milliamps of current difference, or more than 5 milliamps, then this is designed to trip. And that's important because humans, if we were to touch this and complete the circuit, both the hot and the neutral screws, then this will trip at 5 milliamps. But if it did not trip, that means that this current can hurt you more if it's above 10 milliamps. At 10 milliamps, you lose muscle control and you get a pretty bad severe shock. So these are very important to have, or GFCIs, because they protect personnel. All right, now that we have our taped around our receptacle here, now I'm going to go ahead and land it on the box. And this is I'm going to just screw in these 632 screws. And here we go. I like to start off little by little, line them up. And just screw them in. I'm gonna have this as temporary power because in the future I'm gonna have to use this for doing more work here in this garage. But for now, I'm gonna leave it like so. Usually you already have sheetrock installed here. When you have sheetrock, the sheetrock is flush against this box, and these yoke ears here land on top of the sheetrock, and it stays flush with the sheetrock, and it projects this receptacle out a little bit, and you can put a cover plate. But because we don't have any sheetrock, these is going to obviously hit the box all the way through this yoke. But this is just temporary, so we're not worried about that. All right, so now that we've landed that, let's go ahead and land our receptacle. Our breaker. Our breaker. So now this breaker is a square D for this square D panel here. All you do is these grooves here, you gotta insert them here, and your contacts have to land on the hot bus bar. As I mentioned, it's hot, so make sure your breaker's off. And here we go. You go like this, you insert it in, and then you slam it down. All right, now that we have that, let me get my tools that I need to land this. All right, we got this. Ah, man, it's uncomfortable because my knees are still not recovered. All right, same procedure here. We're gonna take our sharp blade and score this Romex. Remember to leave at least 1/4 of an inch of sheathing inside the panel. At the end, you just go tighter. All right, now we're gonna go ahead and remove the sheathing, cut the axis off, we don't need any more, expose the wires, cut this off, nothing like a nice sharp blade. All right, now we're gonna measure our wires. I'm gonna start landing on wires. I like to start off with my ground. So your ground, just land it to your ground bus bar. Just obviously you want to make it look nice and neat, but just fold it in such a way that you're going to keep it nice and neat, remembering that you have a hot panel here, so try not to touch nothing that's hot. Here we're going to land to this ground bus bar. You need a number 2 square tip. Back up the screw, and you can just land it like so. You have a little bit of wire sticking on the other side of the ground bar here, and tighten it down. There's also torque specs for that, but for now that's good enough. Just make sure you have it nice and tight. Back up your receptacle here, and now I'm going to land down my neutral, find my ground, You can pick any of these holes here. Sorry, any of the holes. I meant to say any of these screws. Put on the neutral bar. Cut your excess wire you don't need. Keep in mind this is 12 gauge. You know, you can strip out little. You don't have to strip out little by little, but if at first you're trying to get a hang of it, you can strip out little by little, and once you see how much you need, then you strip out more. Again, you gotta back up this screw here on this neutral bar. All right, now we landed our neutral bar on our neutral part of our sub panel. All right, finally we gotta land our black wire, or a hot wire here. So always give the shape to your wire the way you want it to land and look nice. Fortunately, sometimes it can't always look nice, especially with stranded wire. It's pretty hard to do with stranded wire. Solid wire makes it look, comes out nice. So just strip your wire again, and now we'll be finishing off. And like I said, be careful not to touch your hot bus bar. So I like to strip them and just have them so it's not exposed to hot wire. Oh, you see that? It didn't land. So I didn't do it right. So let me go again. Try to land this. Tighten it down. You can always give them a nice snug pull on it. Make sure it doesn't come off. Pull on the neutral, pull on the ground. Make sure none of them come off. Now you've landed your wire. Now it's the moment of truth. I'm gonna turn on the breaker. If you don't see a mushroom cloud like Oppenheimer, then we know we're good. We know we are good and everything was wired right. So there it is. Now it should be hot. Let's test it. What's the best way to test this? Well, this is a good way to test it, you could say. But let me see if I can find the tool that I need here. I don't see it. Maybe it didn't make it back. Well, oh, it sure did make it back to my tools. That's awesome. The best way to test this is with a receptacle tester. So let's go ahead and we gotta set this GFCI. Now it's set. We have an green LED light, means that it's good. Let's turn it on. All right, here we go. So you can see the correct method here. The lights should be my middle and my right light should be on. That means it's correctly wired. So if that's the case, then we did a good job. And you can also activate the ground fault on this receptacle, and as you can tell, it tripped. Reset it, and again we got our power. So that's how you finish this circuit here. So hope you enjoy, and next time hopefully I can make another video covering other subjects of electrical. All right, you guys have a good one.